All right, I want to talk about this idea of axis of change. It's been around for a while, but yeah, back in 2002, Robert Martin introduced us to this idea in his book, Agile Software Development. And for my money, I think that identifying a system's axis of change has even more utility than his well-known solid or component principles. And I think that's because it gives us a way to figure out the hard part, why and when to refactor an application. Now, it seems like these days there's been a lot of criticism of solid and clean code, and I think that's because, like everything else in software, these things come with trade-offs. Refactoring is expensive, it's risky, and solid was never meant to be one-size-fits-all because while it does enable developers to evolve their application towards a more portable and adaptable architecture style, following these principles willy-nilly can introduce significant complexity. Like, what might have started off as a simple pass-through class can suddenly get refactored into a sprawling modular monolith with dozens of components. But that said, sometimes the juice can be worth the squeeze. So how do we make that determination? Well, Martin writes, a class or component should only have one reason to change. That's the single responsibility or common closure principle. Okay, so how are we going to figure out that reason for change? Well, I like to think that at the edge of every system, if you go far out enough, you're going to find a human actor. And for most enterprise applications, those are the users and customers we built the software for. And of course, we're going to want to accommodate all sorts of different kinds of users. And they're all going to want different kinds of updates and changes, a long list of new features and capabilities. But here's the rub. Each one of them is going to want all their changes made at different times and for different reasons. And if we took a decision early on to build the software with a single interface, flexible enough to accommodate all those different kinds of users, well, then our application's got more than one reason to change. And what's more, there's a good chance that your application's got dependencies of its own, databases, APIs, and any number of third-party services, and they've got their own set of updates and changes, and that's going to put even more pressure on us to have to refactor our application. Now, one easy way to map out all these axes of changes is to go ahead and illustrate the software solution as a use case or component diagram, and with that, the axis of change is easy to spot. That is, every line pointing in from a human or a system actor, and every line pointing out to a dependency, and that's it. Those are the things likely to drive change to our software. All right, let's try it out. Now here we got a basic web application. Call it Hobby Supply Store, an e-commerce site. It's backed with a SQL Server database to store all the application's domain-specific data, like product catalogs and orders. And we got a CRM, Salesforce. That's the source of truth for all the customer data. And as you can see, this web app's been designed to accommodate our three different kinds of users: customer, seller, and admin. Pretty standard. And right off the bat, you can see our axis of change. 5 of them. 3 users and 2 system dependencies. Now let's take a closer look at the web application. We can zoom in by drawing it as a white box component diagram. Show the individual processes within the application context. You can see the supply store's web client is shared by all 3 user types. Maybe they get routed to different pages or views after logging in. Probably design it to be a single-page application built with React or Angular. And for the back end, we got a REST API, a web service that contains all the main supply store business logic. It's a pretty simple monolithic app, easy to build and deploy all at once. But here's the thing. Check out what happens when the customer user wants a change. We'll have to at least redeploy the web client, and that's going to affect availability for the sellers and admins. What's more, any kind of change is risky. Like, say we introduce a bug. There's a good chance it's going to affect all the users, not just the customers. In fact, any change for any one of the user types is going to require some costly regression testing to cover all the use cases for all the user types. What's more is, if we got to make a change to the database, It's going to affect all the users. I mean, it's a good bet that the supply store's web service is going to require changes to handle any updates to the schema, and that's probably going to trickle up into the web client. And we'll definitely have to expand our test strategy to include integration and end-to-end testing, even more costly. Okay, so let's try to mitigate some of that. Maybe we can do some tactical forking to split up the web client, one for each user type. At a system level, that's the interface segregation principle. You can see we got the old supply store web client for the customer, a new supply seller web client for the seller, and of course, an admin web client for the admin user. Here, you'll notice we're trading flexibility with all its complexities for usability. Of course, it's got trade-offs. Now we got 3 web clients to maintain. But look at what that gives us. Let's say we want to modify the customer's user experience. The risk of change is limited in scope to just the hobby supply store web client. The sellers and admins don't get touched at all. Pretty cool. That said, we're still not out of the woods yet. If any changes have got to be made upstream in the database, CRM, or the web service, all 3 web clients are going to be at risk of needing updates, and we'll have to, at the least, regression test all 3 of them again. Whether or not we decide that this was a good idea is going to depend on which axis most of the changes end up coming from. Now, let's say we want to go deeper with some more refactoring and try to protect our application from all those dependency changes. We can zoom in further and check out some of the classes. Here we can see we got the same HTTP client code in each of the web clients making calls to the same controller from before in the REST API. You could say that the web service itself has got 3 reasons to change. 3 web clients making upstream calls to get data to bind to its views. We can reduce that coupling by segregating the web service's interfaces, and now we got 3 lollipops or provided interfaces, and that's going to make all 3 web clients a little less brittle. Cool, now what about those dependencies at the bottom? How are we going to reduce the risk of database and CRM changes to our domain classes and the rest of our applications? Well, we can put a few more of the solid principles to work for this one. Instead of having our domain classes making external calls directly, we can refactor them to make calls to required interfaces instead. This leverages the Liskov substitution principle, and our application is going to behave exactly the same regardless of any changes made to the dependencies. In fact, this sets us up for the open-close principle. The domain classes remain stable and closed for modification. At the same time, they're open for extension by any class that realizes the required interfaces. In this case, that's the Salesforce and SQL client classes. They're going to handle all the repository mapping and calling responsibilities so that the domain classes don't have to know about it. In fact, check this out. Here, I've drawn a boundary around the anti-corruption layer. Look at what direction the dependency line's pointing in. Up, from the adapter to the required interfaces. You might even say it's inverted. That's the dependency inversion principle. Of course, this dotted line is just a logical boundary, but if we wanted to, we could formalize it by putting that part of the code into a separate component or DLL. For now, we'll just keep working on refactoring the classes. Now, finally, let's see where we can apply that single responsibility principle. It looks to me like all that admin code is likely to change at different times and for different reasons than all that customer and seller code, so we can split that out. Of course, it's still going to have a dependency on that same SQL server, but that's a detail that can get abstracted behind its own required interface, and that's what adapters are for. Here, each separate required interface is realized by a distinct adapter that maps a specific set of SQL Server responses to the calling class's expected response. What's more, this is how you can reuse dependency classes like that supply store SQL client down here. The adapter adheres to the SQL client class's provided interface and lets it worry about all that SQL-specific responsibility. And finally, once we've done that, check out what happens when we make small schema changes to the database. The adapter hides any changes, mapping the new response type to the old required interface, and the domain logic up above stays protected. Even better, those breaking changes are no longer propagated up the stack. Those required interfaces keep the rest of the application blissfully ignorant. Now I gotta point something out. You just saw me walk through an architecture roadmap demonstrating how to refactor a web application for all 5 of its axes of change, but here's the thing. You don't have to do it in that order. In fact, you don't even have to refactor all 5 of them. Like, it could just be that you need to protect your application from a series of Salesforce configuration updates, and if so, you don't really need to add the unnecessary complexity that comes with splitting up the interface and adding adapters for the database calls. That's the crux of the common closure principle. If things are going to be changing together at the same time, you're going to want to keep them grouped together. Again, refactoring is never going to be one size fits all. Martin writes, an axis of change is an axis of change only if the changes actually occur. It's not wise to apply the single responsibility principle or any other principle for that matter if there's no symptom. Use the axis of change to identify your system's reason for change and then let it guide you into refactoring only the parts of the system that benefit from the added complexity. All right, that's it. My name's Steve, and thanks for watching.